Write the major products for the following. And that write the first question. People are still coming now. Okay, once you are done, please send your answers on WhatsApp. Okay. You have 4 questions, so I think 5 minutes would be enough. Okay, I've received some answer. Okay, Khalid has sent me an answer. Okay. First one is correct, Khalid, very good. Second one, yep, correct. Third one is also correct. Fourth one is not correct. Fourth one is not correct. Waiting for others. Please try, guys. Please try and send the answers. Send me whatever you have done till now. Okay, Matthew. First one is correct. Second one is correct. Third one is also correct. Very good. Fourth one is not correct. We will see why fourth one is not correct. You also try, na? You see why it is not correct, the fourth one. आस्था आपसे हो रहा है?
Yes, sir.
Like, are you able to do these things? These problems?
So the bond line structure, it
Bond
gets
line structure
confusing.
gets
Thoda sa, like
confusing.
if it's in the formula form, then it's easier to do. I'm getting concept.
Now, this is carbon. Okay, this is carbon. This is carbon. I think you can now पता कर लीजिएगा. Here we have CS3. Now, if you are getting some confusion in bond line, I'm sending you one worksheet. You work through it, and I hope you will be comfortable then. Okay. Asta, I have sent you some one PDF. Try to read whatever you can, okay? But main focus here is that you do the exercises. Okay, you do the exercises. It's very clearly written pages. You'll understand.
Sir,
I hope you will understand. Tell me.
sir, actually, it's a different phone for the timing, different number. I'll text you through that number. You send that PDF in this number.
Okay, fine.
Sorry.
Fine. No problem. I just have to forward it. A few taps on my phone. Nothing else. Okay. Muhammad Umar. Okay, fine. One, two, three is fine, I think. 1, 2, 3 is fine.
So I'm still doing the 4. Okay.
Okay. Okay. So what should I do? Should I keep that number as Asta or should I save this number as Asta?
Sir, this is like my mom's number. For the timing, I don't have my phone. So after I get it back, then tell that this number.
Okay,
I'll
for the
tell
class
for the
timings,
or
right?
this number.
Okay,
For
okay,
like a
fine.
week or two, maybe this number at least. Saved it.
Okay, okay, okay. Okay, fine. Oh. Hishma, everything is correct except the fourth one. Fourth में आपने थोड़ा mistake कर दिया. It's fine. Let us see. Fourth वाला इसका नहीं हुआ अभी तक सही. First one is correct, Salman. Second one is correct. नहीं, second one सही नहीं है आपका. Please see, Salman. You are in a hurry, it seems, huh? Third one is correct. Okay. So first of all, Astha, can you please send the answers?
Yes, sir.
Whatever you
Send it.
Okay. Okay, so let us look at the first one here. So here what will happen? This CS3 from Grignard reagent will attach here on this carbon atom and hydrogen will attach on the oxygen. So we'll get CS3 OH and then the CS3 from Grignard reagent. Okay. Similarly here everything will be same. Hydrogen, here we had CS3, here we'll get oxygen OH and one CS3 from the Grignard reagent. Now whatever carbon atom is present, that we are going to add on the carbonyl carbon. Yeah, correct. Now here also hydrogen, oxygen will get hydrogen and this carbon atom will get CS3. Now let us look at this one here. What is this group, guys? And what is this group? This is ketone and this is carboxylic acid, right? Now, if you go to carboxylic acid, you will see that carboxylic acid can only be reduced by LiAlH4. That means this NaBH4, it will not affect the carboxylic acid. Carboxylic acid will be as it is, but it will convert the ketone into alcohol. So this carboxylic acid is as it is. And this is OH. Okay, so sodium borohydride NaBH4, it is selective. It selectively reduces ketone and aldehyde, and it does not reduce the carboxylic acid group. Okay. So those who have not done, please write the answers. And since Umar, you were asking, let me tell it now only. See, we don't have this bond. Okay, this bond is not there at all. We have O negative and Mg positive. You got it, Muhammad Umar?
Yes, sir.
Yeah. So this is O negative and Mg positive, and that is why we can easily introduce here. If I add some acid, okay, H plus in the presence of water, that means H plus will come and it will bond, make a covalent bond with oxygen molecule it is here. Because if I have H plus, then oxygen atom will give all the electrons and it will form OH. Got it now?
Okay, sir. So O and MgBr are not making bonds at the first step.
No. They are not making bond, correct. So it is, they are completely ionic here. Okay. Completely ionic. It does not have any covalent bond because obviously Mg is not going to form any covalent bond. No? It is what it is. Group 1, group 2, S block element. Oh, sorry. Chali. So I think you all are done. Right, next. I think this is the fourth one. No? Last time, okay, we did 4. This will be 5th. By hydrolysis of esters. Okay, please write. Alcohols are prepared. Alcohols are prepared by hydrolysis of esters with aqueous alkalis. Aqueous alkalis means NaOH or KOH is something like that. Metal hydroxide will be there, and you will be preparing this alcohols. So we have R. A general reaction will be R, C double bond O, O, R dash. Okay, O, R dash. Now here, if I add NaOH, now this Na will be in water as Na positive and OH will be as OH negative, right? So what is going to happen? In this particular thing, this R is getting delta positive and O is what? Delta negative. O is delta negative. So we'll get this OH to attack here. This oxygen will break the bond like this. We'll take all the electrons and we will get R, C double bond O, O negative, and this Na positive will form a salt. Okay, plus we will get R, and OH from the sodium hydroxide is getting bonded with the R dash here. So if I have, let us say, CH3, C double bond O, O CH3. In the presence of what? NaOH. So OH will get attached on the CH3 molecule, and this Na will get attached on the COO negative. So we'll have CH3, C double bond O, O negative, Na positive, plus CH3OH. Here we have 2 carbon atoms. CH3, CH2OH. Write this down. This is an easy reaction. Next one is very important. Giving you 5 more seconds. 5, 4, 3, 2, and 1. Okay. Right now, from alkenes. This is the 6th one, and it is very important. From alkenes. Okay, it is very, very, very important. It's very important from the board's perspective also. It has been asked multiple times. You have been asked some products from this reaction. We have also been asked the mechanism of this reaction. So please write. alcohols are prepared by, right? Alcohols are prepared by right here. Alcohols are prepared by alkenes by acid catalyzed by acid catalyzed hydration by acid catalyzed hydration. Then right, when alkenes react with water in presence of, when alkenes react with water in presence of protic acid. Protic acid means you have an acid which gives protons. It is not a Lewis acid such as AlCl3 or FeBr3. It is a Bronsted acid which gives you H plus ions. Protic acid, they undergo addition reaction and form alcohol. We'll write next. The product formed is Markovnikov product. What does Markovnikov product means? It means OH group will attach on more substituted carbon atom, meaning the carbon atom with less number of hydrogen. So write a general reaction. You have carbon, double bond carbon, which is a generalization of alkene, and we have some groups attached here, and we add water in the presence of an acid, and we get what product? We get alcohol. So this pi bond will break. Okay, so in the double bond, one of the bond will break. These two bonds are as it is, and we get two new bonds. One of the carbon atom will get hydrogen, and the other carbon atom will get OH group. Okay, and this addition here is Markovnikov. Okay, this addition here is Markovnikov. Right, this general reaction, and then we will do some problems also. Okay. Asta, have you heard of Markovnikov addition or Markovnikov rule?
Yes, sir.
Okay, fine.
Sir, can you scroll it up?
Little up. Why are many people late today? Hania was there. Hania, I think she again left. Nawal, what happened? Why are you late today? Acha, Hania is also here. Hania was also late. Yes, Nawal, what happened? I could not hear you. And Hania, what about you? What happened, Hania? Why are you late?
Sir, I was having internet issues.
Okay, fine. Did you get the marks for the last test, Hania? आपने
Yes,
दिया था
sir.
टेस्ट? मिल गया आपको ना? Okay. Saif, आप भी late हैं? Why are you late?
Sir, I was breaking from my fast.
Okay. Okay. Done all of you?
No, sir.
No. जल्दी लिखिए. Also write this alcohols are prepared now. You just write here number 1 because we look one more reaction from alkenes. One is by acid catalyzed hydration. And then the next one is by reacting this with diborane. We call that hydroboration oxidation reaction. Look at that also. Done everyone? Yes or no? Please tell me. How many of you are done now? Raise your hand. How many of you are done? Okay, most of you are done. Please take a screenshot, guys. Please take a screenshot. I hope you have taken by now. Okay. So next we'll be looking at the some products. Okay, some reactions here. Please pay attention. Okay, please pay attention, guys. Write the first one. CS3 CH double bond CH2. I will react this with water in the presence of an acid, a protic acid, that means which gives H plus ion. Now, according to Markovnikov rule, we have two different carbon atom across the double bond A and B. Which is having lesser number of hydrogen? Tell me, guys, which is having lesser number of hydrogen? Which is having lesser number of hydrogen?
B.
A.
Oh, B कौन बोला? आस्था, A ना? Lesser number, lesser. Yes, Astha?
Yes, sir.
Okay. So OH will attach on that carbon atom which is having lesser number of hydrogens. So we'll have CS3, CH, single bond, and then hydrogen will attach on what? This carbon atom. So we'll get CS3 here, and the OH will attach on this carbon atom. Okay, OH will attach on this carbon atom. Fine. Let us see next. So this is from what? This is from open structure. But see, in bond line structure, you will get this type of molecule. This above structure and this bond line structure both are same. Okay. Plus H2O in H plus, we'll get OH in the second carbon atom like this. Okay. Now, you can't see hydrogens in the bond line structure. You can't see hydrogen in the bond line structure. Okay. So what you are going to see, you are going to see how many bond it is making, how many single bond it is making. So how many bonds, single bonds can you see from this carbon atom? This green one. This green one is making one single bond here, and it is making one single, then the double. No? So it is making how many? Two. This green one has two bonds or two alkyl groups, you can see. Okay. But what about this one here? This blue one? It is attached to only one carbon atom. Okay. So it is more substituted. Kaun sa more substituted hai? Second one is more substituted than the first one. Okay. Green one is more substituted. So I have written here both the things. Please see. OH group will attach on more substituted carbon atom, meaning the carbon with less number of hydrogen. So both of the things are there. If you have bond line structure, then you will apply the more substituted one. And if it's not, then you will apply the less number of hydrogen one. Right. The third case. Now in this case, tell me. Green or blue? Where should I attach? A or B? Tell me, guys, where should I attach the OH atom? A or B?
So we can attach on either of them.
On either of them, right? Yeah, correct. On either of them, because both of them are same. आस्था आपको आ रहा है?
Yes, sir.
Okay. चलिए, write the fourth one. Write in chat A or B. Where should I attach? Where should I attach the OH atom? A or B? Hania, what is the condition? Can you tell me what is the condition? कैसे देखते हैं? OH will attach on which carbon atom? Ask Hania.
Yes, sir.
हाँ, आप क्या देखती हैं ये बताइए हमें आप. What do you see? What is the difference A and B में? And how do you choose it?
It was my mistake, so it's supposed to be B.
No, I'm not asking that. I'm asking कि आप क्या देखती हैं? What do you look? Which carbon atom? Are you getting my point, Hania? I'm not asking the
Yes.
answer. I'm asking the process. How do you decide whether it is A or B? Yes, Hania. You have written this ना in your paper. Notes में लिखा होगा ना कहीं पे आपने. Where will the OH group attach? No.
Yes, sir.
Tell me, read that sentence then. I have not got answers from Nawal. I have not got answer from who else? Hishma ने दिया answer. Okay. Hishma ने नहीं दिया answer. I have not got answer from Hishma. And Khalid has also not given me answer. Saif ने दिया है. Saif ने दिया है. Yes, Hania, I'm asking something now.
The one which
Yes.
has more carbons.
The one which has more carbon. Okay. So this B atom has how many carbon atoms? Tell me.
2.
And A has how many? It has 2 carbon atoms. And A has how many carbon atoms?
1.
1. Okay, fine. I mean, except the double bond, right?
Yes.
Other
yes.
than the double bond. Other than the double bond. Okay, fine. Great. Take it. So all of you have answered it correctly. So this will be as it is. And this B carbon will get the OH. And you will leave this A1 as it is because we don't show the hydrogen. A is getting the hydrogen, but we don't show the hydrogens in bond line structures. Okay. So this is my molecule here. Right. Some more questions. And you will send these answers to me on chat, okay, on WhatsApp. Please, if you get confused, mark the carbon atoms of double bond, then look at each of them and decide which is having more number of substituents. Okay. Whenever you get confused, mark the 2 carbon atoms. That is the first thing that you are going to do. And then count it. How many alkyl groups are attached to each carbon across the double bond. Okay, I've got some answers, I guess. You see. Okay. Yes, Asta, very good. Correct and correct. Very good, Asta. Waiting for others, guys. Please send it fast. Okay. Ishma, correct, correct, and correct. Very good. Muhammad Umar. You have made a cyclohexane. It's not a cyclohexane. It's cyclopentane in my question, 7th one. But it's not right. CH2 will become CH3, Muhammad Umar, no?
Oh, yes, sir. I'm sorry.
Yeah.
Yeah.
It's fine, no problem. Okay, Saf. Oh, Saf, आपने तो mistake कर दिया. See? Which is having more alkyl groups? Saf, tell me. Green or blue?
Sir, can you repeat?
Which of the carbon atoms is having more number of alkyl groups? A or B? Say A is attached to 1, 2, and 3. And B is attached to how many? 1 and 2 only, no?
Yes.
So A will get the OH. 7th one is correct, and the 6th one also is correct. Okay, Matthew. Yes, Matthew, correct. All are correct. Very good. Oh, Khalid का कुछ गलती हो गया था. Khalid. अच्छा, let me write the answers. That's it. Actually, write it down, those who have not written it. Then we will look at the mechanism here. I'll wait for 5 more seconds and then we'll start the mechanism. Okay. Now, for mechanism, I will do a problem that is CS3, CH, double bond CH2. And what happens if it reacts with H plus in the presence of water, okay? It will give me CS3, CH, CS3 and OH here. Why are we getting this product? We will try to understand this part. Okay, we'll try to understand why are we getting this product here. Okay, so for that, write the first step. Now, in the first step is protonation of alkene. In protonation of alkene, actually what happens is, first of all, our water molecules, they react with H plus and they form H3O plus. Okay, the structure of H3O plus is how? The structure of H3 plus is oxygen and it is attached with 3 hydrogens and a positive charge on oxygen atom. So this is H3O plus ion. And since oxygen is electronegative on its own, now it has an additional positive charge. That positive charge is also pulling the electrons of hydrogen atom in the bond, and oxygen, which is already electronegative, that is also pulling. That what is happening? There is a strong pull of electrons from the hydrogen atoms, and it gets a very high delta positive charge. And when this alkene CH3, single bond CH, double bond CH2 gets in the vicinity and in the surroundings of this H3O plus, this attacks on this hydrogen atom because hydrogen is electron deficient and pi bond, it has very extra electrons. Now what can happen? First thing first, it will happen is that this bond between oxygen and hydrogen will break and it will give its electron to oxygen atom, making water molecule. Now this pi bond is breaking, but this hydrogen will either get attached on the first carbon atom or the second carbon atom. So we'll write the products in both ways. We'll write this as 1 and 2 in the blue. Let us write this as B and then make the product. Now what is going to happen if the hydrogen of H3O plus gets attached on the first carbon atom? So we'll get CH3, CH was there, so CH2, it will become single bond CH2 positive. But if the carbon atom B gets the hydrogen, then we will have CH3. The CH will be as it is, single bond CH3, and this middle carbon will get a positive charge. Now we know that this is 2 degree carbocation, this is 1 degree carbocation, and 2 degree carbocation is more stable. This is more stable. And that is why the further reaction will occur via the 2 degree carbocation. So first of all, protonation of alkene, it has given me a carbocation, major carbocation, which is 2 degree. Step 2 is the attack of H2O. Attack of water molecule on this carbocation. Have CH3, CH3, positive charge on the carbon atom here, and we have H2O molecule. This H2O molecule will attack on this carbon atom, leading to formation of CH3, CH, CH3, and O, H, and one positive charge here. Okay, now the last one is the deprotonation. Last step is deprotonation. Third step is deprotonation. If you look at this entity here, it is similar to what we have here. Oxygen with a positive charge and 3 different bonds. Oxygen with a positive charge and three different bonds. It is very similar to that position that we have already seen, and that is why the water molecule will come again and it will take one of the hydrogen atoms. So we'll have CH3, CH, oxygen and two hydrogens, a positive charge here, and one CH3 molecule here, plus there will be H2O. From H2O, this oxygen will come and it will attack on this hydrogen atom, one of the hydrogen atom. And since that hydrogen atom is delta positive, we are going to get CH3, CH, OH, CH3 plus H3O plus. Now, since the H3O plus is already, it has been consumed in the reaction, but it has already come back once again. We started with H3O plus. The initial reaction was with H3O plus, and we ended up with H3O plus also. That is why it is used as a catalyst, and it is not getting consumed. It is reacting. It is taking part in the reaction, but it is not getting consumed in the reaction. Okay. So please write this mechanism, three-step mechanism. The first one is protonation, attack of H2O, and then deprotonation. It's very easy to remember also. The first one is protonation of alkene, second one is attack of H2O, and the third one is deprotonation. Write the three steps. Let me know if you have any doubts. Raise your hand when you're done, okay? Please raise your hand when you're done. Okay, Astha. Okay, it seems most of you are done. I will wait a bit more and then I will start the next topic, that is hydroboration oxidation reaction. Okay. So moving on. Write the next topic. Hydroboration. This is also from alkene, okay? This is the second reaction that we can 2 with alkene. Please write hydroboration. Oxidation reaction. In that, start writing alkenes react with latest. Alkenes react with diborane to form trialkyl borane. To form trialkyl borane, which on further hydrolysis with alkaline H2O2 with alkaline hydrogen peroxide gives alcohol via anti-Markovnikov addition. Okay. So a simple reaction will be CH2 double bonded with CH2. Okay. Now there are many variations in how you will be given this type of question. The first variation is in the first step you will be given BH3, and this BH3 will be in the presence of THF, tetrahydrofuran. Tetrahydrofuran is not a reagent, it is a solvent. The second step we will be having H2O2. In the presence of, you may be given NaOH or KOH or OH negative. So I will be doing all of these different variations. But what will be the product? This CH2 will become CH3 bonded to CH2, and one of the carbon is going to get OH. Okay, one of the carbon is going to get OH. Now, please write the second case. Now, let us see if you have CH3, CH, double bond CH2, and we are going to have the same condition with a bit change. Okay, what you may be given is not BH3, but you may also be given B2H6. Okay, so B2H6 is what? BH3 is not found at room temperature in a monomer. It is found as a dimer, that is B2H6. And that is why you'll be given B2H6 sometimes. And instead of NaOH, you may be given just OH negative. H2O2 in the presence of OH negative like this. But still, it is again what? Hydroboration oxidation reaction. And here we are going to get via anti-Markovnikov rules. That is why you will be getting CH3, CH2, CH2OH. So the carbon atom with less number of substituent or more number of hydrogen, less substituent and more hydrogen is going to get the OH. Right, next. If I have something like this, BH3, THF. The second, we are having H2O2 in the presence of OH negative. So in this case, I will be getting CH3 will be as it is here. This double bond will break, and I will get OH in this carbon atom. Anti-Markovnikov rule. Please write the product.
So 1 minute, can you show those examples?
Sure. Send me the answers on chat, okay? Send me the answers on WhatsApp. Sorry, not chat. Send the answers on WhatsApp. Okay, Saf. First is correct, second is correct, third is correct, fourth is also correct. Very good, Saf. Good going. Okay, Asta. First is fine, second is fine, third is fine, fourth is also fine. Now you are comfortable with the bonding structures also, it seems. Right, Asta?
Yes, sir.
Okay, thanks. Okay, I'm waiting a few more seconds. Please send the answers. Okay, Matthew. Correct, correct, and correct. Very good. First वाले का आपने नहीं लिखा है आंसर, लेकिन I think you cropped that or something.
Yes, I by mistake put a double font.
Okay, first is correct, Hishma. Second fine, third fine, fourth fine. Very good. I hope you guys are finding alcohol, phenols, and ethers way easier than haloalkane, halorine, because once you have written haloalkane, halorine, the subsequent chapters are ought to be easy. Okay, and if you are having any problems in alcohol, phenols, and ethyl, then you have to refer back to haloalkane halorine, because in haloalkane halorine there will be some portion that you are not very comfortable with. You do those things first, then only you will understand. As you can see, Markovnikov, anti-Markovnikov, I did not explain anything. I already based all of these things to what? From the haloalkane halorine chapter. Okay. Muhammad Umar, आप हड़बड़ में हैं. Look at your fourth question and see what is the mistake there. The molecule that you have drawn just above same, that is having only 3 carbon atoms. Above that, it is fine. Third one, I don't know. I don't understand what you have drawn. First is fine. Second is also fine. Third and fourth, I don't know. Please check it now, Mohammed Umar. Khalid, first. Okay, wait a second. Mohammed Umar, your first is also not right. First is wrong. Anti-Markovnikov, na Mohammed Umar. Okay, Khalid, first one is correct. Second one is correct. Third one is correct. Fourth one is correct. Okay, fine. Let me draw the products. So for the first one, we'll have CS3, carbon CS3, a hydrogen, and CH2OH. Okay, so this carbon is going to get OH. Here, this carbon is going to get OH. Not double bond. Just a OH group here. Here, this carbon is going to get OH. For the fourth one, any one of them will get OH. Okay. Tell me. All right, next. The last method of preparation for alcohols is from aliphatic primary amines. From aliphatic primary amines. Please write. When amines react with nitrous acid, when amines react with nitrous acid. What is nitrous acid? Oh no. है ना? आप कैसे याद रखिएगा इसको? What is nitrous acid? It is oh no. Oh no. Nitrous acid. It forms alcohol. So if you have R, CH2, and NH2, and I react this with ONO, then I get here R, CH2, OH. Okay, so you will divide it like this, देखिए. OH, nitrogen, and O. So this carbon atoms get OH molecule, nitrogen gets nitrogen, and this water gets, the hydrogen gets water. So you'll get N2 plus H2O also. Okay. So this is very basic reaction. You can write here, let's say, for example, NH2 in the presence of HONO, nitrous acid. We'll just remove the NH2 and you'll form OH. There is no change in the number of carbon atoms. Okay. Now, even if you have something like this, some cyclomolecule, NH2, the presence of ONO, just remove the NH2 and you will form OH here. Okay. So you write this down, let me know when you're done. Write a question. How would you synthesize? The following alcohols. The following alcohols using appropriate alcohol. Oh, my bad. Appropriate alkene, not alcohol. Appropriate alkene. Okay. So see, I'm giving the first question. I will explain this question, then we'll write the other questions also. Okay. We have here CS3 and here we have OH. Fine. Now they're asking you that this is my alcohol. So what they have given in a reaction, they have given you the product already. They're asking you how will you make this molecule using a proper alkene. They have also given you the class of substrate that you have to use. The starting material should be alkene. The starting material should be alkene. Now we know that there are two different reactions that we can do. We can either do what? We can either do hydroboration oxidation, or we can do what? Hydration. So in hydration, Markovnikov or anti-Markovnikov. So you can see that this product here, it is on a carbon atom that is most substituted. It has 3 carbon atoms on its own, right? So what is the molecule that we can have as alkene? In alkene, we can have this molecule, and in the presence of H plus and H2O, it is going to give me alcohol on this carbon atom. Now you will say that, sir, we can also use this molecule, CS3 and a double bond here. Then I will say, yeah, correct, that is fine. We can have this molecule also, but it is better to have this molecule. Why? Because this carbon atom is 1 degree, and the probability of getting 1 degree carbocation is very less. It is very less. Here we have, this is 3 degree and this is 2 degree. Now we can have some 3 degree and there will be some 2 degree products also. It can be formed, right? So it is better to have a 1 degree carbon atom and 3 degree carbon atom. So the alcohol will be formed only in the 3 degree carbon atom. You will not get any 1 degree carbon atom forming any alcohol. Okay, so this is the product that you are going to get. This is my alkene here. This is the alkene. Similarly, if you have something like this, CS3 and OH. Now see, this is my carbon atom where we are going to have, this is the carbon atom where I am going to have the hydrogen, sorry, the hydroxy group, the OH group. And these are the carbon atoms, this green carbon here, this red carbon here, and let us say this yellowish type of carbon here. Now all of this green, red and yellow, they can have a double bond, but I will prefer to have the double bond on the green carbon atom because it is 1 degree carbon. Okay, so I will have this molecule as alkene. Double bond CH2, and I will react this with H plus in the presence of H2O to get here CH3, OH, and the other alkyl groups as it is. For the third one, right? We have OH group here. Now this carbon atom, which is having hydroxy group, it can have a double bond either with this green carbon atom or the red carbon atom. Now tell me guys, which one would you prefer, green or red? कहाँ पे double bond होगा तो बेहतर होगा? Where should the double bond be? Green or red? Which will be better?
So green.
Red.
Green. No, green, na. See, 1 degree carbon. We are always preferring 1 degree carbon. We are always preferring 1 degree carbon. Please remember it. Green one. What about others? समझ में आया नहीं आया? आस्था, नवाज, सलमान. Tell me guys. Saif,
Yes, sir. Yes, sir.
Yes, sir.
right?
Yes.
Okay. So we'll have double bond here plus an H2O. I will get OH here. So this is the carbon atom with hydroxyl group. I can have a double bond here, a double bond in this carbon atom, or a double bond here on the yellow one. Tell me, where should I have the double bond? In the red, green, or
The
yellow?
red one.
All of you agree with this? Yes or no? Tell me.
Yes, sir.
Yes, sir.
Please remove the OH group, है ना? यहाँ पे सिर्फ आपके पास क्या होगा? CH2 and then H plus and H2O. यहाँ पे बताइए रेड और ग्रीन. Where
Green.
should I have the
On red.
Yes, can you explain why red? Khalid, can you explain why red? Khalid, what happened? I can't hear you.
Sir, because it's more stable than the green.
तो रेड एटम में क्या करना है हमको वहां पे बताइए. वो बात ही नहीं है ना, आप तो बात ही नहीं समझ में. हमको अनस्टेबल चाहिए ना. आई डोंट वांट अ स्टेबल थिंग. अगर रेड वाले कार्बन पे डबल बॉन्ड लगाने से वो ज्यादा स्टेबल हो जाएगा तो OH वहां भी आ सकता है. सही है. We can have, if it is more stable, then we can have OH there also, na? Are you getting my point?
Yes, sir.
So we want the double bond in that carbon atom which is the most unstable. एक तो आपके पास ये हाइड्रोक्सी ग्रुप है. This is on the second 2 degree carbon atom. Okay. तो यहाँ पे हाइड्रोजन में अगर हम यहाँ पे डबल बॉन्ड लगाते हैं, यहाँ पे this will be what 1 degree. ये मेन कंसेप्ट आप लेके चलिए. Okay, first of all. But in this case, I will tell you it will be red atom. Why? हम ये आपको बता देते हैं क्यों. In this case, it will be red because we can have this one or we can have this alkene. है ना? If I have this alkene, then there are two probabilities of product. We can either have OH on this carbon atom or we can have, this is my required, this is my target material. We can have this target material, right? But there is possibility of two products. There is possibility of two products, even though this will be major. But if I have a double bond here, then I can get this OH plus this OH, which are same only. Yes or no? All of you agree with this? Both of these are same? Yes or no,
Yes,
guys?
sir.
Tell me.
Yes, sir.
Right? Both of these are same, right? That is why in this case, whenever you have a chance of forming, whenever the alcohol can be formed with symmetrical alkene, then you are going to do this product. Okay. But ये सवाल कभी आया नहीं है CBSE में. Okay. It has never came in CBSE. We'll get only these type of questions. You have to see that we are having a 3 degree alcohol or we are having a 2 degree alcohol. There is no chances of forming any. There is no chance of forming any symmetrical alkene. Okay, there is no chance of forming any symmetrical alkene. And what you see here that we have 1 degree carbon also. So we'll always make a double bond with 1 degree carbon. Okay, चलिए. I hope you have written this. If not, then please write it down. Let me know when you're done. So this is my preferred one.
So can you zoom out a bit more?
A bit more. फिर दिखेगा ही नहीं कुछ. More.
So I haven't written anything. So I will take a screenshot.
Take a screenshot. Astha, you're asking something? Yeah, done.
Done, sir.
Oh, done. Okay. Fine. So that is it for today. Okay. In the next class, that is on Thursday, we'll be completing the preparation of phenols. And we will also do physical properties. Phenols preparation, there is not much. Because see, in alcohols, we have at least 3 types of alcohol that we can form: 1 degree, 2 degree, and 3 degree. There are many variations that you can have in the structure of molecules of the substrate also. But in phenols, you are just going to form benzene with OH, no matter what the substrate is, right? So you have to remember just the substrate and the reagent, you will always get phenol. There is no Markovnikov or anti-Markovnikov rule. So it is relatively easy and quick to finish. So in the next class, we'll be doing preparation of phenol. Secondly, we'll be doing the physical properties, and we will touch upon the chemical properties of alcohol. Okay, chemical properties of alcohol. Now, in preparation of alcohol, you have to keep in mind about 3 things. The first thing that is very important is the reduction of aldehyde, ketones, carboxylic acid, esters. Okay. The important thing is that this carboxylic acid can only be reduced if you have LiAlH4. Okay, and these can be reduced if you have both of these can be reduced only if you have LiAlH4, and aldehyde and ketone can be reduced even if you have NABH4 or weak reducing agent. Second, very important thing is the preparation of alcohols with Grignard reagent. In Grignard reagent, you will see that there are 3 different types of product that you can form. The first is if you have formaldehyde. Second is if you have any other aldehyde. And third is if you have ketone. If you have formaldehyde, you will form 1 degree. If you have other aldehyde, you will form 2 degree alcohol. If you have ketone, you will be forming 3 degree alcohols. The third case that we have done today is from alkenes. Now in alkenes, you have to remember there is 2 methods. We have either H+ in the presence of H2, or we have hydroboration oxidation reaction, which is BH3 in the presence of THF, and then we do H2O2 in the presence of OH negative. Okay, so these 2 methods, this is Markovnikov addition and this is anti-Markovnikov.